Okay, so the issue was related to our uh, to the Golang compiler. So we had like a different compiler version, and the path was pointing to a different Go version. So I fixed it using Claude, and yeah, just to now show the example. So this is a very basic Go program where we are using this wait group. Without this wait group, if I don't wait for this thing to end and I try to run this program, the program will exit without printing anything because we are not waiting for these go routines to finish. So we are not waiting for these go routines to finish. Now if I wait for these go routines to finish, only then when they have done their thing, this program will end. So you can see that I have written this time.sleep, which is waiting for 1 second, and it is printing the numbers in like uh, in a variable order. So like there is no fixed order to print these numbers, and now when it is completed with that, it is ending the whole program. And I wanted to show something equivalent in Rust. So in Rust, how do you write this thing? So we don't have a concept of threads, concept of go routines in Rust, but we have these threads, and I think that they are OS level threads. I will just confirm it with Claude after some time. uh, so this is how you write it. So you spawn a thread spawn, and you just print the variables, you sleep for some time, and you get a handler when you spawn a thread, and you just wait for this handler to finish. So like there are multiple threads running at the same time, and then inside the main routine you are waiting for all these children routines to finish. So you're just waiting for both of them to be completed, and only after that the main routine exits. So this is the equivalent way of printing numbers uh, in like no particular order in Rust. And yeah, now just to go to the Claude. So this is something that I created here. What is the difference between Rust threads versus coroutines? Uh, so yeah, so create like the more thread we create, like each thread uses 2 MB of memory for some reason. I don't know why they are using 2 MB here, must be some particular reason, but obviously thread uses more memory as compared to go routines. So go routines can be considered as lightweight threads, and we can like create hundreds of them at once, and even then they won't consume a lot of memory. Must be because like thread has its own set of stack or something. So let's go here. So obviously the Rust threads are actually OS level threads. They're 1:1 mapped, while green threads, while go routines are green threads. So like one thread can handle multiple go routines, and memory per thread is around 2 MB, which is like the whole stack here, but it is only like 2 KB initial stack for each go routine. And creation cost is high in case of Rust. It is like operating system syscall, okay, and very low in case of Golang, which is like runtime managed, and they're cheap, expensive. So yeah, these are the basic differences. Yeah, and the scheduler is the OS scheduler. So uh, our operating system itself schedules like which thread to run at what point of time. But in case of Golang, the Go runtime schedules that which go routine to handle at what point of time. And obviously, what okay, so we are doing this stress test and creating, oh my god, 1,000 go routines, and it took only 2 MB of memory. But if we do the same here, like for 50 threads, I think it will take a lot of memory. Okay, it's taking like 100 MB memory for all these threads in Rust. So yeah, uh, so Rust threads are OS level threads. Go routines are not OS level threads. They are green threads like managed by the Go runtime itself. But these Rust threads are actually operating system threads, and they are managed by the operating system. It uses this syscall thing to like spawn a thread, so it's quite expensive. Um, yeah, so this is it for the video. I wanted to basically show how you can spawn a thread in Rust, which is equivalent to Go routine, which is like useful for Go programmers. Um, okay, I will see you in the next video where we will explore the move operator, especially like if you have some variable that you want to move to like you want to move inside the thread. So yeah, this is something that we will cover in the next video. So see you in the next one.